All right, everybody. Welcome to my second talk for FlutterCon Uganda. I hope you're all having a good time. This one is about bringing Google Maps to Flutter. And once again, I have to say, I wish I could be there with you in person today. Unfortunately, it didn't work out this year. Maybe next year again. But you can always reach out to me via email or LinkedIn. I'll share my LinkedIn credentials at the end. Right. I want to just introduce myself a little bit. I am a freelancing mobile app developer. I do, at the moment, mostly small projects. I haven't always been a mobile app developer. I started out actually on the back end and slowly worked my way towards app development via Android and eventually landed on Flutter. Um, I divide my time between South Africa and Germany. And in fact, at the moment, I'm in South Africa. I'm calling to you from Stellenbosch, South Africa. I'm a certified Google developer expert for Flutter for the last 2 years. That's a program by Google that highlights community contributors. And I'm also a very, very proud member of the Flutteristas. Now, Flutteristas is a network of female Flutter developers. They are the most awesome bunch of people, super supportive. So if you are a Flutter developer, a woman in the audience, please do yourself a favor and sign up for Flutteristas. It's a really helpful network. But enough about myself. Let's talk about what we want to accomplish today. So I want to build a demo app with you. In fact, we are not going to build it live together, but I'll walk you through the steps. So I had this problem a while ago that I wanted to build a delivery app. Now, if you know me better, you know Christmas trees figure big in my life. So let's think, just for the purpose of this talk, think about delivering Christmas trees. So the basic functionality is there should be geocoding. So geocoding means turning an address into latitude and longitude coordinates. So that's kind of the customer gives you a delivery address and you need to find it on the map. Then we want to have map markers and preferably customize them. We want to display routes, the driving route to that marker, and we want to calculate distance and driving time. And then the kicker of this is we want to do all of that for Android, iOS, and the web. So this is part one of my presentation. Part two is going to talk a little bit about what we can do if the functionality is there. There are third-party packages that we're using, but they're not quite hitting the spot. And I'll show you some coping strategies. All right, so this is what we talk about. Google Maps is a big suite of products. There is the Google Maps platform in the cloud, and it, as I said, it's a big set of products. It's not a single Google Maps product. There are a bunch of different APIs. I think about 33 or 34 altogether. Stuff like directions and geocoding APIs. That's the ones I'm going to use today. But then there's also, there are so many different ones. So routes and places are just two examples of them. So those are the standard APIs. On Android and iOS, there's also, in addition, a native Maps SDK for Android and iOS. These native SDKs will, under the hood, call out to the various APIs, but that basically happens transparent to us. As a Flutter developer from our Flutter app, we can connect directly to the native SDK on Android and iOS, and then that one will make the calls for us. The advantage is that these native SDKs are for free. So if they do any work with the Maps API, we don't pay for it. On Chrome, that looks a bit different. There is no option of embedding a native SDK. Chrome always has to do an API call to the JavaScript API, and these calls are charged. So there is a fee for using this interface. So that's just the basics. Now let's think about what else we need to do to get a project off the ground. So first, there are a few things you have to do. You have to have a cloud account. So you have to set up an account, you have to set up a project, and then in this project you have to enable billing. There is no way around this. Now, billing doesn't necessarily mean you get charged. There's a very generous free tier. I think it's about, last time I checked, it was about $200 per month. So that means the first so many map requests are free, but eventually you'll exceed that budget and you will be charged. So that's why you always have to put down a credit card. And then on top of that, so this here is kind of a snapshot of your Google Cloud profile. So in addition to enabling billing, you have to enable a few interfaces or a few APIs. So what you need for the purpose of this talk is the Maps SDK for Android and for iOS, the JavaScript API for your Chrome requests, and the Directions API. And then finally, you have to generate an API key. Now, you could get away with a single API key, but it's good practice to generate one for each platform you want to target. So in my case, Android, iOS, and web. So that's the prerequisites. Now let's set up a project. So I'm going to start with a skeleton project, and I need to add 3 different libraries to get started: Google Maps Flutter, geocoding, and Flutter polyline points. Google Maps Flutter is released by Google. It's basically, that's the bulk of all the maps functionality. Geocoding and Flutter polyline points are packages that are provided by third parties, and I'll talk a little bit more about them later. And there are a few more steps you have to do. The first one is you have to pin the minimum SDK. And so this is on Android. On Android, the minimum SDK has to be at least 20. Now, it actually turns out that's not such a hardship, because currently Flutter's default is already 21. So, pinning it to 20 is really not that much of a restriction. The next thing is you have to provide the API key. Now that's the key you generated in the setup. You can just put that straight into your manifest, but it's a bit of a security risk because you don't want this key to be checked into your public GitHub repo, for example. An API key should be treated like a password. It would allow other people to use your account and basically get your credit card charged. So make sure your API is protected, and one good way to do that is to use Dart defines. So that means the API key is only injected at runtime. Now we're moving on to the iOS side. There again, we have to pin the minimum platform. So in this case, it is 14, and this has to do with the Android store privacy requirements. And then again, on the iOS side, we can use Dart defines. The setup is a little more complicated, and I'm not going to talk through it in detail because it's a bit of a distraction here for the purpose of this talk, but you can read up on it in this really, really awesome blog article. By the way, I'm going to share the slides at the end of it, so no need to take screenshots. So I'm going to share all of this with you, so you can look up this blog article yourself. But basically, if you follow the directions, this is what you end up with. Let me see if I have another slide. Yes. So you need to find your appdelegate.swift file, and that's basically where the Flutter system kind of inflates itself. And there you need to provide the API key to GMS services. And that rather than pasting the API key in directly, you're using the Dart defines directory that you just set up. So much for iOS. Now let's move on to Chrome. Here you have no choice but to put the API key into index.html. Alternatively, you could use the Bootstrap loader script. This is a newer mechanism you can read up on it. There are plenty of tutorials about setting up Bootstrap Loader. So that is all we have to do as a setup. So now it's time to add a first map widget. So what I want to do is kind of, for this purpose of this demo app, I want to have a very simple demo app with a single page, a single widget filling that page. So here my single page has a scaffold. It's a stateful, my demo view is a stateful widget, and that becomes more important later. And in the scaffold, I use the Google Map widget, and this widget is provided by Google Maps Flutter. And it has a bunch of different parameters, but two of them are interesting in my case, on map created and initial camera position. So on map created is taking a callback, and this callback basically allows, the Google Map widget creates a controller during setup. And now this controller is useful to access outside, and we basically need to hand that over. So that's what this callback does. It's called with my controller variable, and it basically assigns the internal controller to my controller, basically hands out control. So that is on map created. And then the other one was initial camera position. Initial camera position tells the map widget how to start up, where to center, and how much to zoom in. So here I'm giving it a point, a latitude and longitude. I could also give it a bounding box, but I chose a single point. This happens to be some location in Berlin. And then I use a zoom factor. I picked 14, it can be bigger or smaller depending on your needs. So what does this give us now? Here is my first map, and this is actually the web view. So I see my map fills the page. It is centered on, I think this is the center, the Messecube Berlin. Zoom factor is good enough that you have some details but don't see all of Berlin, so you can adjust that as you wish. But by and large, this already looks pretty good. However, it's still just an empty map, so the next step would be to add some markers to it. So just to create a single marker. So with marker, I mean these pins that show kind of important things on the map. So what I do is in my stateful demo widget, I want to create a list of markers. And then in its state, I add marker objects to these. These marker objects are widgets or objects that are provided by the Google library again. And the most important parameters they have is there is a mandatory marker, unique marker ID. Then there's a position. Obviously, that's kind of the location of your marker. Otherwise, how would you draw the marker? And then there is the info window. Now, this info window is basically the little pop-up that you see when you click on a marker, and that shows you more about what this marker is. So in my case here, I just gave it a title and a little snippet. All right, so this marker is added to my list in init state or with set state. So that means every time a marker is added, my widget rebuilds. And when it rebuilds, it takes the new list of markers and hands it to the Google Maps widget. And this basically, with the marker being part of the state, takes care of all the updating or so. Whenever there's a change in marker, this will rebuild and the new list of markers will be presented. And this is how it looks. Here I have Chrome. This is Android, I believe, and this is iOS. Might be the other way around. I don't quite remember. But basically what you see here is my red little pin. It looks pretty much the same in all platforms. And then you see this info window. Now that looks quite different on the different platforms. And that's a little bit of a nuisance, to be honest. There's no easy way around it because the info window or the entire pin and info window is created by the underlying SDK, not by Flutter system as well, itself. If it were Flutter, it would be easy to modify it and make sure it looks the same on all three platforms. But I don't have complete control over this, unfortunately. Right. The red pin was nice, but now we can do a little more with it. I would like to customize my marker a little bit. And basically what I wanted to do is have a cute icon that I recognize, and then have like some extra status information that shows me the state of a delivery. Is it urgent or not? Has it been finished already or not? That kind of stuff. So it turns out when we create a marker here, we can add an optional icon. That is a bitmap descriptor, and that basically shows what to draw. Now the default marker is this red pin. And the first thing we can do is we change the color. We can give it a default marker with hue. And the hue is basically determining the color. So that's a first step. But that's still not a lot, then you just have colored markers, colored pins. The next step is you can actually provide a custom asset. So you can have your own iconography. You can have kind of upload pictures, photos, graphics, whatever you choose. But they have to be uploaded during build time. So they have to be part of your build system. That also means you can only have so many different pins and colors. They all have to be pre-generated. And then they can be added to your marker in this form from asset image. And that's pretty good, but in my case, it wasn't quite appropriate because I wanted to determine at runtime how my marker should look. So for that, there is the third option. I can generate markers, I can generate bitmaps dynamically with bytes map bitmap. You can give it a size and the bit information, and that bitmap will turn into your new icon. Now that third method was perfect for my need. And then I got this inspiration from another really awesome blog post that I found quite useful, how to use Google Map markers with Flutter material icons. And what this guy discovered, and I built on top of that then, is that basically you can create your own bitmaps from scratch, and you don't have to actually create it from scratch. You could use a material icon and paint that onto a canvas and then use that as your bitmap. So here I'm using a material icon called park, and that's basically a little tree symbol. Now every time you have an icon, it's basically just a character in a character set. It just happens to be that character set is, rather than A, B, C, D, E, it is all icons. So basically the character code is a position in that character set. So we need to find that, turn that into a string, and then basically just paint this character icon onto a canvas. So this sounds a bit confusing when I talk through it, but read the blog post. It's quite interesting, and it explains the process quite well. So basically, what I did now, oh yes, so you end up here with a bitmap, and then we can add that custom bitmap descriptor that we generated to our marker object, so as a fourth parameter here. Now this gets us something like this here. I magnified these just so that you can see them better. So here is the basic home icon. And this is like two icons overlaid. So this is my park icon, it's the green tree in green. And then I put a red check mark slightly smaller and centered over it. With this, I want to display the status of this order. So, you know, yellow is for medium urgency and red is for super urgency. And, you know, you can play around with this. You have lots of options. So that was magnified. In reality, this is the normal size. So here is my icon in the Chrome view. Here it is in Android, and this is the same in iOS. So you see they look different, they look the same, they are the same size. There are some blog posts that claim the sizes were distorted, but that's not longer the case. That problem has been fixed. All right, moving on to the next thing, address lookup or geocoding. There are 5 different steps now. The first one I will not mention anymore, which is basically capturing the address. So that's like adding a form field to your view that allows the user to enter an address and hit submit. Once submit is hit, we have an address string that needs to be converted to coordinates, lat long. Then we have the new coordinates. We need to create a marker at that position. The next step is we need to recalculate the bounding box. Now the bounding box is kind of the imaginary box that you can imagine around all your markers. Let's say you have 10 different markers on the screen. You want to zoom out the screen so that all 10 are visible and centered. And if you add an 11th marker somewhere far out, you want to reschedule, or kind of zoom in, zoom out, and kind of reposition your map to make sure all 11 markers are shown. And in fact, this is done in the 4th step. After the bounding box is calculated, the 4th step does the scaling and centering. So this is the code that gets all of this done. Here is step number 1, converting the address to latitude and longitude. So we are calling geocode address and it returns a lat long. Step 2 is creating the markers. So I build a function getMarker that takes the lat long and the address and returns a marker. Step 3 is calculating the bounding box. That gives us coordinates. And then step 4 is use those coordinates plus a bit of padding to update the camera. And for that, we use the map controller. So let's look at each step in a little more detail. Step number 1 was converting the address to lat and long. And I already told you I have a geocode address function here that takes an address as input and returns lat long. So this is the first time now I'm using a new third-party package called geocoding. Geocoding has a function called location from address that takes an address and returns a list of locations. Oops, too quick, sorry. Now, list of locations means it's a list of locations, not latitude, longitude. It's a list because you never know whether an address will resolve. So it might be a nonsensical address that doesn't exist, then you get a null result, or it might be an address that's not unique. So then you get maybe 2 or 3 results. And either way, I'm getting my list of location points back. Each package has their own notion of data objects, of location, and but they can easily be converted from one into the other. So here I'm taking the first element. No, I'm taking all the elements. I'm converting the location into latitude, longitude, get a list, and then somehow deal with it. What do I do if it's not empty or if there are more elements? There has to be a little bit of error handling code. I simplified this a little bit. I just assume I have one result and return the first result. So this is basically my geocoding lookup using the package geocoding. Step number 2 is creating a new marker. And since I already talked you through the whole marker business, I'm not going to do that again. Step number 3, this one is quite simple. It is pure and simple, very simple math. It just uses minimum and maximum and takes all the existing points, finds the biggest and the smallest latitude and the biggest and the smallest longitude, and calculates the bounding box from there. So that's not rocket science. It's just a little bit of min and max operations. And then the last step is recentering the map. Now you can probably see why I was so obsessed about getting a variable with the map controller before, because the map controller now allows you to take an existing map and update that map and even animating it in the process. So you simply give it new coordinates, and then the map controller will take care of doing a smooth animation to that new bounce. So I have a video here, but let me show you the live demo. So here is my Android emulator and my map demo running. I'm having my home directory here as my home marker is in Cape Town. So let me add a new address. Let's say Long Street, Cape Town. All right, you saw how the new marker was added, and then the map not actually that slowly, it happens quite quickly, but it zooms out and repositions the app. So let's try something else. Cape of Good Hope. Okay, again, the map zoomed out. Now let's go crazy and say Kampala. All right, now we have the southern part of Africa in view. And so the map controller does all of that automatically. Right, so for this step, I use the geocoding package, which is quite nice. It uses the native map SDKs for Android and iOS, which means that my lookups are for free. However, there's a downside. It does not support the web. And that was a bit of a problem for me, but I'll talk in part 2 about how I dealt with this. Okay, there's one more step, which is polylines. Now with polylines, I mean basically the line that's drawn on the map that shows my driving directions. I want to get from point A to point B, and I want to have a turn-by-turn description, and I want to have the map display my route. So for this one, I use the Flutter Polyline Points package, which under the hood accesses the Directions API. This package gives you a list of waypoints as lat-long points. It also gives you distance and duration. And then I can use these waypoints to generate the actual polyline object in Flutter Maps and with Google Flutter. So Google Maps Flutter has a polylines object that gets a list of waypoints to generate itself. And then these polylines get displayed on my map. The term polyline is a bit overused here. Both the Google Maps Flutter package are talking about polylines, and the third-party package as well. The two objects are slightly different, but you get the drift once you start playing with this. All right, so what did I need to do? In step 1, I wrote this function get polyline segment that takes a start and an end. And here I'm using the third-party package Flutter Polyline Points. And more specifically, I use this get route between coordinates function. This takes the API key because it's doing an API call. It takes the start and the end, and then it also takes a travel mode. And that one returns a polyline result, which is not quite the polyline I need in the end, but it gives me a list of waypoints, basically a list of coordinates. Again, there's a little bit of conversion from one format into the other. In the end, I want to have lat-long, which I'm doing here with this map operation. And now, once I have my waypoints, I can create a Google Conform polyline object. It has and this should look very familiar because it's very similar to the marker object. It has a unique ID, polyline ID, and then it has a bit of styling information. So in my case, I gave it the color and the width. And then it has a list of coordinates. The waypoint had the marker had a single coordinate only. The polyline has a list of coordinates. Now, once I create this new polyline, I need to add that to my state. So before I only had a list of markers, now I also have a list of polylines. I add my polyline, and that will cause my Google Maps object to be redrawn, because it's a state change. And rather than just getting the new list of maps, it now also gets the new list of polylines. And this is how it looks then. Here I have my start point and two endpoints and kind of the green line of driving directions in between. Now remember, for this step I use the Flutter polyline points package, which under the hood uses the directions API, and this is a paid service, it's not for free. So just be mindful that each request costs you money once you exceed the $200 per month. But the beauty is it also returns distance and direction. I didn't display that here, but you can easily imagine how you have an info window now that shows you, driving distance is 2 kilometers and takes 45 minutes. The polyline package also has a lot more complex operations, so you can rather than only giving 2 points, you can have additional stopovers and so on. So do explore the full complexity here. Now, this is kind of almost what I wanted to accomplish, but there are two issues with it. Number one is the Flutter polyline points package has a bug. It turns out it's actually, by now it's fixed, but when I made these slides, the direction and duration was wrong for multi-stop routes. It was okay for a single stop route, but not for multi-stop routes. Again, this bug has been fixed, but I'm going to talk through it anyway here because I think it's a very good exercise in how to address these issues. So that's number one. Number two is the geocoding plugin does not support web at all. Now this is a problem for me because I said I wanted to support all three platforms. So where does this leave us? I think it's not a challenge, but an opportunity. And it allows us to look a little bit at coping strategies that we can employ when we face the situation where a third-party package, or any package for that matter, any Flutter library or package that we rely on, is good, is helpful, but isn't quite hitting the spot. So there is some issue with it that doesn't quite work for our needs. So what I want to show you now is just general strategies on how to cope with this. I want to make clear I'm not picking on these two packages. I'm just using them as examples for scenarios that you encounter every day. And, I want to show you how you can jump in and basically add your own work to somebody else's work. So let's start with the Flutter polyline points package. This is the easier one. And it's actually a package, not a plugin. That means it uses Dart code only, no native code. And it's basically a fairly simple wrapper. It's actually really nicely written and you can read through it. It makes a lot of sense. All it does is it provides a fancier interface with type checking to issue an HTTP request to the JavaScript API, the directions API to be specific. So it takes all the arguments, puts them into the correct form, sends this request off, receives the result, and parses it into a form again that the user expects. And in fact, this is where it goes wrong. So somewhere where the result is parsed, if you do a multi-point route, the result will have multiple polylines, multiple waypoints, lists of waypoints, and also multiple driving directions, durations and distances, because basically for each segment separately. And rather than adding them all together and say the total is 2 hours 20, it only returns the first result. It also uses still the somewhat outdated directions API, so it would be ideal in the long run to maybe use the route API. Now, when I looked at this, it was fairly clear what happened. It was like a very simple oversight by the author, but still kind of the package was not quite working the way I needed it now. So what do you do in this situation? So what I decided is, so it turns out this package is authored by a single author. The problem has been documented, or had been documented already at the time when I looked at this. There were other people who had already submitted fixes. I didn't quite like the fixes that they had proposed. I wanted to make a slightly different twist, but basically I saw what they had done. And I was pretty sure that the author would eventually accept one of these fixes. But for now, he hadn't done it. Now, I didn't want to sit there and wait and just hit refresh every day and see if the author had taken the time to apply the pull request. So what I did is I made my own pull request that was basically changing adding to the existing work and making the twist I wanted. I submitted that as a pull request, but it wasn't accepted that. And then I had my own modified repo, and I could just link to that. I mean, you don't need to link to a public package only. You can also link to your private package, or maybe to your package that is maybe not private, but that exists in your GitHub repo. So this is what I did here. And I was pretty sure this would be a temporary fix only. I was 100% sure, and in fact, that's exactly how it worked out. After a few days, the author of this package became aware of the issue, applied one of the pull requests, and I was able to remove this line from my code again and switch back to the full package. So this basically, my code repo just had a tiny little tweak on his work, and now I'm using his work again. So that was the first part. The second part was a little more complicated, the geocoding package. Now this package is written by a company called Baseflow, a Dutch company that often partners with Google on official Flutter plugins. Now, in their case, they made a very conscious decision to only support Android and iOS. And the reason is that those two platforms have native SDKs that make maps work for free. If they were to add web to it, it would use a paid API, and it would mix free and paid accesses, which they felt was too confusing to the user and was kind of muddling the water. Now, I completely understand their argument. And again, this is well documented. All of that discussion is documented in GitHub, and it's easy. They explain their reasoning. They said we are not going to add a web interface, and I feel I have to accept that. I feel that I don't have the right to go in there and say, no, you're wrong, you must add this. But I still need the web interface. So what can I do? Well, luckily, there's a solution. So their package, geocoding, is a Flutter plugin. It uses a more complicated architecture than the last one. As it uses method channels, platform channels, to talk from the Flutter plugin to the underlying native SDKs, so iOS and Android in this case. Not only is it a plugin, but it also uses a special architecture, federated plugin architecture. Now, this turns out to be a really cool thing for me. So here on top is my maps demo. My maps demo calls the geocoding package. The geocoding package is basically just an empty shell that calls 3 more packages. It calls the geocoding platform interface, which is also fairly lightweight. It just defines a bunch of signatures. It defines these 3 functions. And then it has the 2 platform-dependent packages, geocoding Android and geocoding iOS. And each of these packages implements those interfaces, those functions, for one of the 2 platforms. So that does the actual work. It sets up a method channel, a platform channel, sets up the message sending, handles the result, and so on. And each package does that for one of the platforms. Now, if you have this architecture, so these are called endorsed packages, but you can also add unendorsed packages. So you're completely within your right to add a new package called geocoding web, or however you want it. Geocoding web would be good convention. And then this geocoding web can do whatever. It just must implement the geocoding platform interface. And then when you do that, your code can from there on use geocoding everywhere kind of without really any distinction, like which platform am I on, what am I using. The architecture will take care of all of that for you. So this looks then in your pubspec YAML, you include the geocoding package, and you also include your extra contribution here, your unendorsed package. Because it's unendorsed, it's not automatically included. You have to include it manually, but you can include it. This can be a repo now, but it can also be just your local directory. It doesn't matter. Now, in this case, I decided to keep this local because I was not comfortable to check this in, but you could also kind of submit this back and make it accessible to the community. So with these two changes, basically, my demo was finished. I was able to accomplish everything I had set out to do. And I hope I convinced you that the process is fairly simple and that Google Maps integrations are really powerful. It's just so visually stunning to see your location, your points on a map and see the whole interaction with the map. So I had a lot of fun during this project, and I hope you play around with it as well. The packages to start with, I can absolutely recommend. There's no way around Google Maps Flutter, but also geocoding and Flutter polyline points are both pretty helpful. But I mean, this is just the basic functionality. There is lots more functionality in all these various maps APIs. So look around and see what's there. And so finally, I also hope I convinced you that, especially beginners are usually quite intimidated by other people's work, third-party packages and so. But, don't be intimidated. Look at the source code, take it apart, add your own work to other people's work. Lean on others to make yourself as productive as you need. And with that, I think I'm done. This is my contact information, and if you scan this QR code, you get this exact slide set that I just presented. So all the links that were in that slide set and all the code examples, and so you can access and study at your own time. Also, please feel free to reach out to me. Best is LinkedIn for me. And yeah, I hope that when you actually watch this video, I'll be able to connect online for some Q&A, but if not, you can also contact me privately. And that's it. Have a good day. Enjoy the rest of your conference. Bye-bye.